Hey everyone, George here, and this is part 4 of binomial expansions. This is the bonus level. These are questions that, in my opinion, are offensive, they're rude, they're just downright depressing. I want us to go through with this. Are you ready? Hold on to your calculators, let's go.
Okay, so for question 1, they tell us when 1 minus 3 over 2x to the power of p is expanded in ascending powers of x, the coefficient of x is minus 24. So for part A, we need to find the value of p. Now this question is different from all the other questions we did. Why? Because now we don't know what the power is. And this might trip a lot of people up. And when this type of question has come up with the students that I tutor, it causes a lot of confusion. So let's go through this right now. First of all, let's expand 1 minus 3 over 2x to the power of p with a binomial equation. So we get 1 to the power of p plus pc1 multiplied by 1 to the power of p minus 1 times minus 3 over 2x to the power of 1 plus pc2 times 1 to the p minus 2 times minus 3 over 2x squared plus pc3 times 1 to the p minus 3 times minus 3 over 2x all cubed. Now in the question they tell us that the coefficient of x is minus 24. So we can simplify that second term, pc1 multiplied by minus 3 over 2x. And that would equal minus 24. Now hang on a second, what is pc1? We can't now put that into the calculator. It won't work. We can't get an answer. So now let's remind ourselves back to the beginning where we went through the formula. NCR is equal to n factorial over r factorial multiplied by n minus r factorial. So now PC1 can be rewritten as p factorial over 1 factorial times p minus 1 factorial. And that would be multiplied by minus 3 over 2x. And because 1 factorial would be actually equal to 1, we can simplify this fraction into p factorial over p minus 1 factorial. So now comes the question, okay, how can we simplify this fraction now? Let's give a very similar example. Let's say we want to divide 4 factorial by 3 factorial. So when we write that out, that's actually the same as 1 times 2 times 3 times 4 divided by 1 times 2 times 3. So as you can see, we can actually just cancel out the 1 times 2 times 3 in the numerator and denominator. So now we're just left with 4. Similarly, p factorial over p minus 1 factorial will simplify to just p. So now carrying on, we would get p multiplied by minus 3 over 2x. And that just simplifies to minus 3p over 2x. Now remember, they told us that the coefficient of x is minus 24. So minus 3p over 2 is 24. Putting that into equation form, we can now cancel out the negatives. Then after that, we can multiply both sides by 2. We then get 3p equals 48. Then we can divide both sides by 3. And then we're left with p equals 16. And that's it. Okay, so for part B of the equation, we need to find the coefficient of x squared. Okay, so the coefficient of x squared lies in the third term of our expansion, and that will simplify to pc2 multiplied by 9 over 4 x squared. So now we can just write that down here. And now that we know what p is, we can rewrite it as 16c2 multiplied by 9 over 4x squared. 16c2 is 120, which will multiply by 9 over 4x squared. And then that all simplifies to 270x squared. Therefore, our coefficient to x squared is simply 270. And finally, for question C, we want to find the coefficient of x cubed. So our last term in our expansion, we can simplify it to pc3 multiplied by minus 27 over 8 x cubed. And when we write it down here, we know that p is 16, so we can just rewrite it as 16c3 multiplied by minus 27 over 8 times x cubed. 16c3 is 560, so when we times it by minus 27 over 8 x cubed, we just get minus 1890 x cubed. Therefore, our coefficient to x cubed is simply minus 1890. Okay, for question 2. In the binomial expansion of 2k plus x to the power of n, where k is a constant and n is a positive integer, the coefficient of x squared is equal to the coefficient of x cubed. So for part A, we need to prove that n is equal to 6k plus 2. So again, business as usual, we're just going to plug this into the binomial equation. 2k plus x to the power of n, when we expand this, it becomes 2k to the power of n plus nc1 times 2k to the n minus 1 times x plus nc2 times 2k to the power of n minus 2 times x squared plus nc3 times 2k to the n minus 3 times x cubed. Now, since only to the term x cubed is mentioned, I'm only going to expand it up to that point. I don't think we have to go further than that. Now, they mentioned that the coefficient of x squared is equal to the coefficient of x cubed. This is very important information. They never give us information for no reason. So, let's look at the coefficient of x squared. That can simplify to nc2 times 2k to the n minus 2. And the coefficient of x cubed, that is nc3 times 2k to the power of n minus 3. And they mentioned that they're equal to each other, so we can equate them. So now we have an equation to deal with. Let's make our lives easier. What we're going to do next is we can divide both sides by 2k to the power of n minus 3. So now we get nc2 times 2k to the n minus 2 over 2k to the n minus 3, which is equal to nc3. 2k to the n minus 2 over 2k to the n minus 3, we can actually simplify that. Because they have the same base 2k, we can take away the powers. So that would be the same as 2k to the power of n minus 2 take away n minus 3. And that just simplifies to 2k to the power of 1, which is just 2k. So now we have nc2 times 2k equals nc3. Much more nicer and much more simple. So now, using our equation for NCR, like we did in the last question, we can rewrite NC2 as n factorial over 2 factorial multiplied by n minus 2 factorial times 2k as usual equals, and instead of NC3, we will write n factorial over 3 factorial multiplied by n minus 3 factorial. And using our knowledge of factorials, we know that 2 factorial is the same as 1 times 2, so it's just 2. And 3 factorial is going to be equal to 6, just to simplify that even further. Okay, so now looking at the fraction on the left hand side of the equation, we want to simplify n factorial over 2 times n minus 2 factorial. If we were to write this down in an expanded form, the numerator would be 1 times 2 times 3 times blah blah blah. It will keep on going until n minus 2 times n minus 1 times n, which is right at the end. The denominator would look like 2 multiplied by, and then we have n minus 2 factorial, which is essentially 1 times 2 times 3 times etc 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 until n minus 2. Now what's really nice is that we can actually cancel out 1 times 2 times 3 blah 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 up to n minus 2, and we can cancel that out on the numerator and the denominator. So now actually what we're left with is n times n minus 1 over 2. Okay, so now how are we going to simplify the right hand side of our equation? We have n factorial over 6 times n minus 3 factorial. Again, very similar. The expanded form would look like 1 times 2 times 3 times blah blah blah, all the way up to times n minus 3 times n minus 2 times n minus 1 times n. And then in the denominator we have 6 times n minus 3 factorial, which is basically 1 times 2 times 3 times etc. all the way up to times n minus 3. We can cancel that part out in the numerator and denominator, greatly simplifying our expression, and now we're left with n times n minus 1 times n minus 2 over 6. So now we can rewrite our equation as n times n minus 1 over 2 times 2k equals n times n minus 1 times n minus 2 over 6. So looking at this already, we can just cancel out the n's on both sides of the equation. Not only that, we can cancel out the n minus 1's on both sides of the equation, and now we can just multiply both sides by 6. So then we get 6 times 2k over 2 equals n minus 2. That simplifies to 3 times 2k equals n minus 2. Then further simplifying it, we get 6k equals n minus 2. Adding 2 on both sides, we finally get n equals 6k plus 2. And that's our answer for part A. Again, we're only needing the formula for NCR and the binomial expansion formula. We don't need anything else. Okay, so now for part B. Given also that k is 2/3, expand 2k plus x to the power of n in ascending powers of x up to and including the term x cubed, giving the coefficient as an exact fraction in its simplest form. Okay, this is a really nice question. So using our expansion to 2k plus x to the power of n from part A, we see that k is 2/3. Well, guess what? We can plug that into our formula for n. So since n is equal to 6k plus 2, which we already found out, plugging in k, we get n is equal to 6 times 2/3 add 2, which simplifies to n equals 6. So we can now plug this in fully to our binomial expansion. So 2k plus x to the power of 6 now, we get 4/3 to the power of 6 plus 6c1 multiplied by 4/3 to the power of 5 times x plus 6c2 plus 4/3 to the power of 4 times x squared plus 6c3 times 4/3 to the power of 3 times x cubed. We can go on, but we're only doing it up to the term x cubed. And now to simplify everything, that should simplify to 4096 over 729 plus 2048 over 81x plus 1280 over 27x squared plus 1280 over 27x cubed. And as horrible as those fractions look, this is as simple as we're going to get, and this is our answer for part B. Okay, so for question 3, we are really taking things up a notch. So let's look at part A. When 1 plus x over n to the power of n is expanded in ascending powers of x, the coefficient of x squared is 3/8. Find the value of n. Okay, so what makes this question a little bit more crazy, a bit more difficult than the last one, is that now we have n not just as a power, but as part of the binomial expression itself. Again, we use the same principles, same method that we have used in the other questions in this video. We will expand 1 plus x over n to the power of n as being 1 plus nc1 times 1 to the n times x over n plus nc2 times 1 to the power of n minus 1 times x over n squared. So for part A, they told us that the coefficient of x squared is 3/8. So now let's try to find an expression for the coefficient of x squared. So for that third term in our expansion, we will simplify that to n factorial over 2 factorial multiplied by n minus 2 factorial times x squared over n squared. 2 factorial is just simply 2. And going back on how we simplified the factorials in the previous question, we know that this would simplify to n times n minus 1 over 2 multiplied by x squared over n squared as usual. Now already we can see that we can cancel out the n here and the n squared to just n, leaving us with n minus 1 over 2n times x squared and n minus 1 over 2n being equal to 3 over 8. We can write that out as an equation. Then we can multiply both sides by 2n. We have n minus 1 equals 6n over 8. We times both sides by 8. We get 8n minus 8 equals 6n. Rearranging that, we get 2n equals 8. Then n is equal to 4. Now we know that n is 4. Let's look at question B. 1 plus kx to the power of n is equal to 1 minus 4x plus 7x squared when expanded in ascending powers of x up to x squared. Find the value of n and k. Now, I'll be honest, parts A and B don't have anything to do with each other, but I felt that these questions are too good not to miss. So after this, we will be prepared for any kind of binomial expansion question you will come across. So looking at question B, let's expand this. We get 1 plus kx to the n equals 1 plus nc1 times 1 to the n minus 1 times kx. Plus nc2 times 1 to the n minus 2 times kx squared, and according to the question that is equal to 1 minus 4x plus 7x squared. Now using the formula for NCR, we're going to rewrite NC1 and NC2, so our expansion will now turn into 1 plus n factorial over 1 factorial times n minus 1 factorial times kx plus n factorial over 2 factorial times n minus 2 factorial times k squared x squared. Simplifying that further, we get 1 plus kn times x plus k squared n times n minus 1 over 2 x squared. Kn is the coefficient of x, and we are told that the coefficient of x is minus 4, so kn is minus 4. We can rearrange that to give us an expression for k. So k is equal to minus 4 over n. we can see that k squared n times n minus 1 over 2 is the coefficient of x squared, and the question tells us that the coefficient of x squared is positive 7, so already we can write the formula that k squared times n minus 1 over 2 is 7. Using the first formula, k is equal to minus 4 over n. If we substitute that value of k into our equation, we get minus 4 over n squared times n minus 1 over 2 equals 7. We multiply by 2 on both sides, the denominator 2 disappears, and we now have our equation equal to 14. Expanding this a bit more, we have 16 over n squared times n minus 1 is 14. We can cancel out the n's, so we can cancel out one n here and one n there. So now we are left with 16 times n minus 1 over n, which is equal to 14. Timesing by n to the other side, 16 times n minus 1 equals 14n. We expand the brackets now, 16n minus 16 equals 14n. Further rearranging that, we get 2n equals 16, and now we get n equals 8. Using our value for n, we can now put that into k equals minus 4 over n. Therefore, k is minus 4 over 8. Therefore, k is minus a half. And that's it. We found k, we found n.
And that is pretty much everything. After all this, you should feel confident enough to pick up any kind of binomial expansion question, and you should be able to smash it. And that's it. I hope you enjoyed it. If any of you come across any harder questions than these, comment it down below. I want to look at it. Maybe we can do some future videos another time. Who knows? It'll be great to see that. If you found the questions helpful, give it a like, give it a comment. Give us a subscribe. If you haven't found it helpful, tell us why in the comments below as well. And I'll see you hopefully in the next video. George out.